I will now looking to explain general trends of ionization energy across the period down the group. I've chosen these points as these points are the mark scheme points that you must talk about when explaining general trends. As you go down the group, there are more shells, so there's an increase in shells. As you go down the group, there's a higher atomic number, so there's an increase in atomic number. If you go down the group, because there's more shells, there's an increase in radius. And the attraction from the nucleus is going to decrease because the size of the atom is going to become bigger. So if the size of the atoms become bigger, less attraction, easier to lose the electron. So as you go down the group, the ionization energy is going to decrease because of these points there. Decrease in ionization energy, and if you was to explain it, you would go back and you would use these points in your answer. If you're going across the period, the shells and shielding stays the same because the period number is the number of shells. The proton number is going to increase. Because the shell stays the same and the protons increase, the nuclear charge actually pulls the electrons closer towards it, so the atomic radius will decrease. If they do ask you about atomic radius, refer back to points 1 and points 2. So if the atomic radius becomes smaller, that means the attraction for the nucleus is going to increase. So therefore, there's going to be more energy needed to remove the electron. So if you look at the periodic table again, when you're going across the period, like so, the ionization energy is going to increase. So as you go down the group, ionization energy decreases. Use these points here to explain your answer. As you go across the period, the ionization energy increases. Use these points to explain your answer, and if they do ask you about atomic radius, just talk about the shell shielding stays the same, protons increase, so there's more attraction from the nucleus. You could also include point 3, point 4 there as well, and therefore the atomic radius would become smaller.